Welcome, zero and all, to our Maths Career Day 2022 with some special numbers and formulae. I am I, and I'll be your host for today. We also have a special guest speech later by the most beautiful equation. As you all are aware, I is an imaginary number, and well, it's complicated. Today, we will not be focusing on any themes since I was supposed to come up with it by last night, and I didn't. Isn't that neat? And on that promising note, let's start from zero.
Hi, I'm Zero. But you can call me by my other names too. Zip, Zilch, Nada, Not, Nil. Zero has so many possibilities. When added or subtracted by another number, it leaves it unchanged. But when multiplied, the product is zero, and division by zero is undefined. Although zero is neither positive nor negative, it's still classified as an integer, which means it's a whole number, a natural number, a rational number, and also a real number. While some people may consider me as nothing or the absence of a value, I'm actually very important. Firstly, we wouldn't even be able to express numbers such as 10 or 100. Without me, the concepts of negative numbers and complex numbers could not have been defined. We wouldn't even be able to solve simple equations without zero. Every single application of math in the real world would not be possible without me. A world without zero would mean a world without computers, which I cannot possibly bring myself to imagine.
Ooh, I've never thought about zero like that. Now let's hear from the Pythagoras theorem.
Hey, I'm the Pythagoras theorem. It's nice to meet you. My inventor was called the father of numbers, and he made pretty big contributions to philosophy. I'm just over 2,500 years old, and I'm pretty useful if I do say so myself. I'm used very extensively in architecture to lay out tiles, figure out staircase lengths, and build slope roofs. I'm also used to figure out steepness of hills. This helps with map making and surveillance. In addition to this, I help with two-dimensional navigation, which basically means that I help planes figure out when they start their descent while landing. That's it from me. Thank you.
Wow, that sounds wonderful. Now let's hear from the Collatz conjecture.
Hi guys, I'm the Collatz conjecture. I have supposedly not been proven, and I'm still called a conjecture, but let me tell you, up to like 2 to the 68th, I've been proven for all numbers. And if you wanted to disprove me, you'd have to start at about 300 quintillion. That's a really big number. Anyway, my conjecture states that for all numbers, for all integers, if you start, if it's odd, you go 3 plus 1, you multiply into 3 and add 1. And if it's even, you divide by 2. And eventually, if you repeat it enough times, the function or the piecewise function should give you 1. That's about me. Bye.
Well, moving on, let's welcome Fermat's theorem.
Bonjour, friends. As you might know, I specifically like being called Fermat's last theorem, but you might not know me, so that doesn't work out. I strongly believe no natural numbers x, y, and z exist such that x cubed plus y cubed equals to z cubed. You see, I'm not quite the socialite. While I might have angered my good old friend Diophantus, I have contributed to the reason all of you crack codes on the internet daily. I believe this fascination is known as cryptography today. Also, many principles of communication are based on my simple yet unique self. Some of your folks even became a little richer by proving me right, by winning numerous money rewards, but very few have actually understood me. I might be called the last theorem, but I like to think that I'm the first of many more to come.
Wow, merci beaucoup, mon ami. Allons-nous à -1/12.
Hi, my name's -1/12, but as you might otherwise know me, the sum of every single natural number all the way until infinity. Now, you might be asking me, I'm just a weird number. What am I doing here? What's my job? Well, I think you'll understand that by the sheer weird nature of this equation and by the controversy that comes with it, I'm a little bit in between jobs right now, which really means I'm unemployed. But I think I have a use that's so much more important than any mathematical application. You know, I didn't become rich and famous because I have some application in design or cryptography. I became famous because I made mathematicians think. I took a group of some of the smartest people in the world and presented an incredible challenge. How could the sum of all positive numbers equal a negative one? And questions like that are what I think math is all about. Presenting yourself with new, innovative, sometimes crazy ideas and coming to solutions about them. To me, that's so much more important than any application math could ever have. So to all of you aspiring young infinite series out there, I'm encouraging you to go out there, step into the world, and give mathematicians something to think about.
Wonderful. And finally, for the most beautiful equation, Euler's identity.
Hello, human children. I am the one and only Euler's identity. To be very honest, I too started off as an aspiring young infinite series, like that wrong -1/12 that you saw earlier. But thanks to my good friend Pi up here, I was able to become the most revolutionary formula there is in math. Po Shen Lo, arguably one of the greatest mathematicians today, has also called me the most beautiful equation in math. Well, despite the fact that no amount of hard work could make one of you into me, doesn't mean that you shouldn't try. I'd like to leave you with something I made myself. A meme, as you guys say. This.
Well, that really went from zero to hero. I think we've all learned a lot today, and I extend my gratitude to all the very busy numbers and formulae that came here today to talk to you guys. While I personally wouldn't want to be, some of these personalities, they're highly celebrated in their fields. I hope nothing that was said today was very complex, and I also hope you all have taken something away from this career day. Thank you all, and good night.
Pi, represented by the Greek letter for P, is a number equal to about 3.14159, though you may also know it as its approximate fractional value, 22/7. I'm sure you've all heard about this number and have memorized one of what you may consider its most important uses, to find the area and circumference of a circle. While your knowledge of this number might only be to this extent, pi is actually used everywhere, such as in calculations for construction, quantum physics, medical procedures, and spaceflight, to name a few. Well, now that we know a bit more about pi,
But Samya, how does pi calculate the area and circumference of a circle? Why does it work?
Interesting question, Shivane. Here's an experiment. Take 4 same-sized pizzas, cut off the crust of the first pizza, and lay it across the rest of the pizzas. You'll find that the crust, or circumference of the first pizza, goes about 3 and a bit more times the width or diameter of the other pizzas. This is why in the formula, circumference equals to 2 times pi times r, or pi times diameter. This number, 3 and a bit more, is pi.
as for why the formula for a circle's area works, try cutting the pizza into very small slices and forming a rectangle with that. You'll notice that the length of the rectangle is half the circumference of the original circle, because half of the crust is on one side and half on the other. And the width of the rectangle is the length of one slice of pizza, which is the radius of the original circle.
The area of a rectangle is length times width, or pi times radius, giving us the formula pi times radius squared. The formula for area of a circle that we know today. But how did people come up with the exact value of pi though?
Pi has been known for almost 4,000 years. The ancient Babylonians calculated the area of a circle by taking 3 times the square of its radius, which gave a value of pi as 3.
The written papyrus from 1650 BCE gives us an insight into the mathematics of ancient Egypt. The Egyptians calculated the area of a circle by a formula that gave the approximate value of pi as 3.1605.
The first calculation of pi was done by Archimedes in the year 220 BC. Archimedes first drew a circle. Then, inside this circle, he drew a hexagon with length of 1. Hexagons can be split into 6 equilateral triangles, so the diameter of the circle is 2. The perimeter of the hexagon is 6. As you know, the formula for the circumference of a pi is pi times diameter. To find the value of pi, we can use this equation's inverse. Pi is approximately circumference divided by diameter. So using this formula in the hexagon, pi is approximately equal to 6 by 2 or 3. But the circle's perimeter is clearly greater than the hexagon's, so pi has to be greater than 3. Now let's draw a square outside the circle, whose side length is 2. The perimeter of the square is 8, and so we note that pi is less than 8 by 2, or less than 4. Well, now Archimedes estimated the value of pi is to be somewhere between 3 and 4, but that's a pretty big range.
But what if, instead of a square and hexagon, Archimedes used a 12-sided shape, or a 24-sided regular shape? He realized that the greater number of sides a polygon has, the closer it is to a circle, and therefore the more precise his range of pi will be.
Archimedes eventually tried using a 96-sided regular polygon and estimated pi to be somewhere between 3.14 and 3.142. His estimation was now accurate to the first 2 decimal places.
A Chinese mathematician in 400 AD used the same logic, but he went through a tiring process and used two 27,860-sided polygons, but was still only able to find the first 20 digits of pi.
Pi began to be used more in the 1700s in the field of mathematics, and now, thanks to the invention of computers, we know the first 6 billion digits of pi. Here are some fun facts about pi. Number 1. Did you know that it took 10 hours for the world record holder to decide from memory the first 67,000 digits of pi? Number 2. NASA uses pi all the time, such as in measuring craters and detecting asteroids. Yes, there's pi in the sky too. Number 3. Finally, March 14th is known as Worldwide Pi Day. No, not that pi. March 14th is also interestingly Albert Einstein's birthday.
Thank you for listening to our presentation on this irrational number. We hope you enjoyed.
Welcome to this year's mathematics match. The rules are simple. I will ask the question, and whoever knows the answer can press the buzzer and share the answer. If you're right, you get 5 points. If you are wrong, we'll move on to the next question. Whoever has the most points in the end wins.
Hello everybody, welcome to this year's Mathet IQ match. The rules are simple. I'll ask the question, and whoever knows the answer can press the buzzer and share their answer. If you are right, you'll win 5 points. If you are wrong, we'll go on to the next question. Whoever has the most points in the end wins. So let's start. First question is, the numerical system which we use today and we know as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 is based on a different system. What is the system called?
The answer is the Hindu-Arabic numeral system.
That's correct. 5 points to Polygon.
Yes!
Question 2. The Fibonacci sequence is a series of numbers in which each number is the sum of 2 preceding numbers. Who was the person who created the sequence?
100% sure that the answer is Leonardo DiCaprio.
You seem extremely confident, but I'm afraid that's incorrect. The correct answer is actually Leonardo Fibonacci. Question 3. What theorem did Andrew Wiles eventually prove in 1995, nearly 3 centuries after it was first formulated by a French lawyer and part-time mathematician?
Oh my god, I know! It's definitely Fermat's last theorem!
That's correct. Question 4. The word 100 is derived from the Old Norse term 100. This word actually doesn't mean 100. What does it mean?
I think the word 100th means 120.
That's correct. Alright, next question. What did the Babylonians discover about the measurement of the circumference of the circle, and what is today's measurement of their discovery?
Oman's circumference is about 3 times the diameter. Today's measurement is pi, which is 3.14.
That's correct. Question 6. As you all know, math is an extremely useful tool and has been for several years now. Roman numerals were first created to make a process easier. What was it?
For last time. I know that the answer to this one has to be to keep track of all the cattle they owned.
Wrong again. Better luck next time. The correct answer was for record keeping, especially in trading. Question 7. Some problems in math have certain names set for them that several people don't even know exist. The square root of 2 has a special name like that. What is it? That's correct. Question 8. Different cultures adopt math differently. One good example is that this is the number 0, and when different geographical locations learned and began to use this number. Yet, one specific person in history is acknowledged as the creator of this number. Who is it?
I think the answer is Bob the Builder.
That's incorrect. The correct answer is an Indian astronomer called Brahmagupta. Next question. Question 9. People have used the symbols addition and subtraction for thousands of years, but as the symbols of addition and subtraction were created in the year 1557, what did the people use to write instead, which was much more time-consuming?
I don't think people even used maths then. Lucky them.
What is Google?
Oh, this is so easy. He's my guru who I go to for the answers to all of my questions.
Incorrect. A Google is 1 followed by 100 zeros. Better luck next time. Now it's time for a big bonanza bonus question. Okay, so it's time for our last question, the big cheese. Let's go back to history for this one.
And for a long time, people used to believe that the earth was flat. But with the help of mathematics, they found out that it was actually round. To prove this, one man planted a stick into the ground, saying that if it would cast a shadow at noon, that the earth would be round. It casted a shadow at noon. With this information, the man deduced that the earth's surface was curved.
Now that you know this, who was the person who discovered that the earth was actually curved and not flat?
Quiz of the year. The person who discovered the earth was round was Epithetus.
And that is correct.
We are done with our questions for tonight, leaving one of our 5 fantastic players as the winner. The winner will get a fully paid vacation to any place they like and title of Mathematics Master 2022. We have counted all the points and we have figured out that the winner is Algebra with 15 points and 3 correct answers. Thank you for watching this year's mathematics match. We're looking forward for next year. Bye!
Morning, miss. Is the chapter trigonometry coming for our term 2 exam?
No, that chapter is not coming.
Thank God trigonometry is not coming.
I know, right? I don't think I would have ever been able to study such a big topic.
Chapter 1 won't come. Chapter 2 we just complete 2 lessons, so it must be very easy.
Exactly, and chapter 3 is too hard and it takes 3 years to practice it.
Chapter 4 is not that hard or not that simple. Let's do that.
All the best for the exam, everyone.
Thank you, miss.
Thank you.
Hey guys, how's your math exam?
What's the equal to sign in this? Netflix, Prime Video, what? Oh no! This is a TV remote! I got my TV remote instead of my calculator. How dumb! How am I ever gonna work out the sums without a calculator? The only hope is the brain. Brain, please help me out here.
Oh my god, I don't know this question right now. What do I do? I barely even studied this topic. Oh my god, not right now. I literally just dropped my calculator. Well, I guess it fell around 45 degrees.
I forgot the ratios. So why didn't I name it so close to each other? Whatever. Never mind.
Yeah, let's not really discuss it.
Yeah, true. Bye.
Where are your papers?
How did you do question number 4? I don't even get it.
You have to use the concepts of trigonometry and then use the cosine rule where two sides and an included angle are given.
Clearly said that trigonometry is not coming for a term paper.
Yes, miss, and cosine rule comes under trigonometry.
But children in maths, all topics are interconnected, so it's always better to practice everything that you've learned.
Miss, why did you cut my maths this? It's perfect.
What sign?
So simple. Opposite by adjacent.
What did you study?
Apple.
Anirudh, I'm very proud of you.
Why, miss?
You didn't forget to write your name in this test. What are you laughing at, Arna?
What did I do?
You put TV channels as your answers for the questions. Charles Caleb Cotton once said, "The study of mathematics, like the Nile, begins in minuteless but ends in magnificence."
Albert Einstein once said, "Pure mathematics in its way is the poetry of logical ideas."
William Paul Pearson once said, mathematics is not about numbers, equations, computations, or algorithms. It is about understanding.
Tala Devi once said that without mathematics, there's nothing you can do. Everything around you is mathematics and everything around you is numbers.
Hi everyone. Today, Srijini, Manya, Isha, and I, Mahika, from the 11th grade, will be exploring the mathematical concept of ratio and proportion. Kindly note that sensitive topics related to body image will be discussed. We hope you enjoy our presentation.
So, the earliest documented dolls go back to the ancient civilizations of Greece, Egypt, and Rome. For example, wooden paddle dolls have been found in Egyptian tombs dating to as early as the 21st century BCE, and dolls with movable limbs and removable clothing date back to at least 200 BCE. Coming to the modern times, in 1959, the first ever Barbie doll was introduced. From then on, she has been receiving a fair amount of critique about an unrealistic body, consumer capitalism, and materialism. The Lamley doll was created by Nicholas Lamb in 2013 when he went on a shopping trip with his niece. In this presentation, we took the measurements of the respective dolls and compared to the average Indian women. The measurements we took include the height, head, chest, waist, inseam or upper leg, and foot. The measurements were input into a chart. We used these numbers to then calculate their size change magnitudes. So the primary concept used here was ratio and proportion.
For round 1, we'll be comparing Barbie's measurements with human measurements. Take a look at this table that we have created. We measured Barbie's height, her head circumference, her bust, waist, inseam, and foot length. We then researched and found the body dimensions of the average Indian woman to use as a comparison. We then accordingly calculated the ratios of Barbie's measurements to the human measurements. When one takes a look at the results, the ratios, they seem completely off for certain body measurements. For instance, the ratio of Barbie's waist to a human waist is 3:25, and the inseam measurements and foot measurements are 1:10 and 1:12 respectively. We wanted to find out what would happen if we scaled up Barbie's proportions. What would she look like? Would she bear any resemblance at all to the average Indian woman?
Now, I'll be talking about what Barbie's proportions would be if she were human. Firstly, her 16-inch waist would be 4 inches thinner than her head, leaving room for only half a liver and a few inches of intestine. Like her fragile 3.5-inch wrists, her 6-inch ankles would prevent her from heavy lifting, making it nearly impossible for her to hold up her body. This is also supported by her children's size 3 feet. As you can see in the table given here, we've compared Barbie's measurements in real life if she were human to that of the average Indian woman's, and the ratios are again completely off. Specifically, her biceps and wrists would be exactly half of that of an average Indian woman's. In addition to comparing her proportions, Barbie would have a severely low BMI of 16.24, and it was also found by researchers that she would not have enough body fat to even menstruate.
We now come to the vastly different lamellae doll. We now come to the table that was generated for the lamellae doll. It has the body parts, the respective measurements, as well as a ratio. As a side note, the measurements of the doll have been taken from the internet since none of us own one of the lamellae dolls, so there is some degree of inaccuracy. However, you can see that the ratios are quite smaller as compared to the Barbie doll, at least, which means that the doll itself is more reflective of an actual human woman's body shape.
What is lamellae? It's the first fashion doll made according to typical human body proportions to promote realistic beauty standards. Nikolai Lamb created it to look like the body of an average 19-year-old with brown hair. Lamellae dolls are much more proportionate to the average Indian woman than a normal Barbie doll. They also come with a $5.99 extension pack, which included stickers of stretch marks, acne, freckles, a mole, cellulite, and even bruises to make her more realistic and relatable.
To conclude, Barbie is seen by and an integral part of children's lives and can be considered as their first exposure to harmful beauty standards. This can drastically affect one's body image, considering Barbie wouldn't be able to survive if she was a real person. Solely by using her proportions, we could conclude that most of her organs wouldn't even fit in her own body.
In contrast, lamellae, a great invention, would help children realize they do not need to satisfy unrealistic and unhealthy beauty standards like Barbie's 18-inch waist, but can have acne, stretch marks, and cellulite. Although Barbie did provide an alternative to restrictive 1950s gender roles, with her career and lack of a stereotypical mother role, this presentation is solely about her proportions and their impact on the current youth.
Thank you.
Hi everyone. Today I'd like to take a couple of minutes to talk about a recent math-related victory for the students of TISB, the Infinity Math competition. Conducted in multiple rounds over November to January, the contest posed many challenges to many of our friends, and I'm glad to announce that we passed with flying colors. The first round was conducted at school. Everyone who signed up through the mail sat in a room and asked to solve 20 math problems in just 15 minutes. Tricky, right? The students were split into two categories. The 9th and the 10th graders were put into the senior category, and the 11th graders were put in the advanced category. From TISB, 15 students were selected. They were split into 5 teams and sent to the second round. The second zonal round. In this round, 150 teams from across the Indian subcontinent competed in 50 teams. It was conducted on the 8th of January 2022 and had 2 rounds. The first round, the individual one, was called Clash of the Mathematicians. All the participants had to answer 30 hard questions in a time of 60 minutes. Then there was the Team Challengers round, a round where teams had to brainstorm answers to 10 questions, again in 60 minutes. From this round, 3 teams from TISB qualified into the final round. Held on January 21st and 22nd was the last one of the competition. Again, our friends went through the same 2 rounds as before, but this time 2 new rounds were added. The first one was Bulb Your Ideas, a team round where teams had to look at a household object and come up with a math question based on it. Some interesting questions revolved around the volume of a beehive and the surface area of a football. Teams had to make PPTs on these, and the top 5 would eventually present. The next round was a mathematical relay race. Teams had 6 questions to solve, and each question could only be accessed when the previous one was solved. Both rounds were unique, fun takes on our favorite math concepts: number theory, geometry, and algebra. As I said before, TISB won big. I'm sure we all know as a school would like to congratulate Unnati and Naman from grade 9, Shivatmika from grade 10, and Akil, Ashna, Avni, Dhruv, R, Shubhayan, Shravan from grade 11 for their efforts in the competition. You may ask though, how did they do it? Well, here's some nice tips to remember if you're interested in math and want to do competitions like Infinity in the future. Firstly, take math courses and programs to expand your knowledge of math. Courses like this exist online at Coursera, Art of Problem Solving, and various other summer institutes. It's also important to practice proactively and on your own. Do some math questions every day or two, just to flex your brain. Timing is a key component of math competitions. Being fast and smart is a great skill to have in your toolkit for math competitions. But most importantly, it's important to enjoy the math experience and all the challenges it offers. Here's a quote from one of our Infinity competitors that truly embraces and embodies the spirit of math competitions. Thank you so much for listening. Congratulations to our friends and teachers, and have a great Math Inc.
Hi, I'm Avni and I'll be talking about the AMCs. So the AMC stands for American Mathematics Competition. It's organized by the MAA, which is the Mathematical Association of America. And the AMCs are considered one of the biggest and most prestigious math contests for high schoolers and middle schoolers. So anybody who's interested in math and math contests should definitely consider giving one of the AMCs. So first talking about the AMC 8. So this is the AMC for people in grade 8 or below who should be 14 and a half years old or younger on the day of the contest. It's usually in mid-January, so the next one will be in January 2023. The format is 25 questions for over 40 minutes, and the syllabus is middle school math. You can find out more details about what's in the syllabus on the MAA website or the Art of Problem Solving website. So what happens if you do well on the AMC 8? A list of high-scoring students is made available to colleges and summer programs, and you may receive an invitation to camps like MathPath. So these are math camps for middle schoolers or camps for gifted students. Yeah. So now talking about the AMC 10. This is the AMC for people in grade 10 or below who should be 17 and a half years old or younger on the day of the contest. It's in November usually, and the format is 25 questions over 75 minutes. The curriculum is high school. The syllabus is high school curriculum up to 10th grade, and no calculus is required. And the AMC 12, this is for grade 12 or below. You should be 19 and a half years old or younger. It's also in November, and in fact, the AMC 10 and 12 happen on the same days. So November, and the format is 25 questions over 75 minutes. The syllabus is the full high school curriculum, and again, no calculus is required. So what happens if you do well in the AMC 10 or 12? Well, the AMC 10 and 12 are the first round in the selection process for the USA Math Olympiad team. So the top 2.5% of AMC 10 scorers and the top 5% of AMC 12 scorers qualify for the AMI. The AMI is the American Invitational Mathematics Exam. Based on your AMC and AMI performances, around 500 people qualify for the USAMO, which is the USA Math Olympiad. Although you didn't need to be a US citizen to give the AMC or the AMI, you do need to be a US citizen to write the USAMO. So from the USAMO, around 60 people are selected for the Math Olympiad program, or MOP. This is a training camp that happens at Carnegie Mellon, and it's taught by expert professors and math competition coaches. So from the training camp, 6 people are selected based on their performance at the camp and all these contests. And these people are selected to represent the US in the International Math Olympiad. So in terms of, for registration, if you want to give any of the AMCs, In normal years, the AMCs are held in person, so you should ask school if they're conducting the AMCs. Usually they do. And if so, the school will register you. Otherwise, you can register through Transitions Lab if it's online. So just Google Transitions Lab Preparatory School and you'll find it. In terms of preparation, the Art of Problem Solving website is probably the best resource. So they have textbooks, online courses, solved past papers, and forums where you can ask questions. You can make an account on Art of Problem Solving for free, although the textbooks and online courses are paid. If you want more guidance on how you should prepare, there's actually a page on the Art of Problem Solving website called How Should I Prepare? The link is here. So they have suggestions for books you could use, study tips like solving past papers, etc. So it's a useful resource. And lastly, here are some books that I like using for preparation. Yeah, so thank you for listening, and that's all there is to know about the AMCs.